What is the call stack, and how does it impact variable inspection? Imagine trying to follow a trail of breadcrumbs through a forest. Each step you take is like a function call in a program. The call stack is what keeps track of those steps. It is a special list that records every function your program is running at any moment. Think of it as a stack of plates, where each plate is a function call. When a new function starts, it gets added on top of the stack. When it finishes, it gets removed. This way, the program always knows where it is in the sequence of function calls. Every time a function is called, a new piece of information called a stack frame is created. This frame holds details like the function's local variables, the parameters it received, and the address where the program should return after the function ends. When the function completes, its stack frame is taken off the stack, and control goes back to the previous function. This process helps the program manage multiple functions running at once. Understanding the call stack is key for debugging because it shows you the path your program took to reach its current state. It reveals which functions were called and in what order. This helps you see the context in which variables exist. For example, if a variable has an unexpected value, looking at the call stack can help you find where it was changed. It's like retracing your steps to find out where things went wrong. Variable inspection depends heavily on the call stack. When you pause your program during debugging, the debugger shows you variables grouped by their stack frame. You can see the local variables of the current function and also peek into the variables of the calling functions higher up the stack. This layered view makes it easier to spot where a variable's value might have changed unexpectedly. The call stack also helps diagnose errors like stack overflow. If your program keeps calling functions without returning, the stack keeps growing until it hits its limit. This causes a stack overflow error, which you might see during debugging as a very deep call stack. Recognizing this pattern can help you find infinite recursion or other issues that cause the stack to grow uncontrollably. It also manages how parameters are passed between functions and how local variables are stored temporarily. Variables inside a function only exist while that function runs. If you change a variable in one function, it doesn't affect the same named variable in another function unless you pass it explicitly. This helps keep data organized and prevents accidental changes. In practical debugging, knowing how the call stack works helps you follow the flow of your program. You can see which functions were called and in what order. This makes it easier to understand why certain variables have specific values. You can also identify when variables go out of scope or disappear. If you see a variable suddenly missing, the call stack can tell you which function ended and why. Mastering the call stack also helps you find recursive bugs. If your program calls a function repeatedly without stopping, the call stack grows larger and larger. Recognizing this pattern can help you fix infinite loops or recursive errors before they crash your program. In summary, the call stack is a core part of how programs manage function calls and local data. It directly influences how you inspect variables during debugging. By understanding its structure and behavior, you can better interpret variable values, trace execution paths, and identify bugs related to function flow. Knowing the call stack is like having a map that guides you through your code's journey, making debugging more straightforward and effective.